Today, let's talk about the ideal gas equation. By the way, I just wanted to greet everyone a blessed Merry Christmas and advanced Merry Christmas. Anyways, let's proceed to the lesson for today. Ideal gas or the ideal gas equation is defined as PV is equal to mRT, whereas P is equal to pressure, V is equals to volume, M is equal to mass, and the R or universal gas constant. Now for air, for its SI units, it is equal to 0.287 kilojoule per kilogram Kelvin. That's for SI units. And whereas for English units, we have 53.34 pound force feet over pound mass Rankine. So pound force feet over pound mass Rankine. And last, we have T, which is equal to temperature. T is equal to temperature. So that's all for ideal gas equation. Let's solve some problems here. So this is given with the following. We have P is equals to 330 kilopascal and V is equals to 4 cubic meter and a mass of 0.2 kilograms. Determine the temperature of the air using the ideal gas equation. First, let's write down the given values. So it would be hard for us to solve this problem. We have P or pressure, which is 330 kilopascals. You have also the volume, which is 4 cubic meters, and given with a mass of 0.2 kilogram. Now, this problem is on SI units since it is composed of kilograms, cubic meters, and kilopascal. So for SI units, we have the universal gas constant of air is equals to 0.287 kilojoule per kilogram Kelvin. Now, let's use or utilize the ideal gas equation. We have PV is equals to mRT. We are asked to find the temperature, so we can divide both sides by mR. We are left with T is equals to PV over mR. We will utilize this formula. Now, we have T is equals to, but let's take note first that 1 kilopascal is equals to 1 kilonewton over square meter. So we can say that 330 kilopascal is also equal to 330 kilonewton over square meter. Now, we are already okay with pressure. Now, let's substitute the volume, which is 4 cubic meters. 4 cubic meters over we have the mass of 0.2 kilograms, 0.2 kilogram, and the value of R, which is 0.287 kilojoule per kilogram Kelvin. Take note that kilojoule is also equal to kilonewton multiplied by meter. We can cancel cubic meters. We are left with meter. We can also cancel meters here. We can also cancel kilonewton and also kilogram. This kilojoule will be cancelled since this is equal to kilonewton multiplied by meter. we are left with the unit of Kelvin. By inputting this in the calculator, we will have an answer of 51 Kelvin. That is our final answer for problem number 1. Now, let's proceed to problem number 2. Let's answer more so we can further understand the ideal gas equation. It says here, if the temperature of air is 75 Fahrenheit, given with a pressure of 120 psi or pounds per square inch, and a mass of 15 pounds, determine the volume in cubic inches. First, again, let's write down the given values. So we have solution. We are given with 120 psi for the pressure, or 120 pounds per square inches. We are also given with mass, which is 15 pounds or pound mass. And we are also given with temperature, which is in 75 degree Fahrenheit. Let's make it absolute. So it will become 535 degree Rankine. So 75 Fahrenheit is just equal to 535 degree Rankine. So the temperature must be in absolute. And we are asked to find the volume in cubic inches. And since this is in English units, so for English units, the value of our R is equal to 53.34 pound force feet over pound mass Rankine. And we are complete with the values. We can utilize the ideal gas equation, which is PV is equals to mRT. We can divide both sides by P, so we can get the volume, wherein V is equals to mRT over P.